Good morning, children. Welcome to today's science class. In today's class, we are going to learn further about light, children. So by now, you all know that light is a form of energy, and also light is traveling. How do you know that light is traveling? Yes. So we are getting the light from the sun. Yes, children. Where is the sun? Sun is away from the atmosphere. So very far, yes, thousands of kilometers away from the earth. Even then we are able to get the sunlight. How? Because the sunlight is traveling. Yes, children. And also when you are in a dark room, as soon as you switch on the tube light, immediately you will see that once the source of light starts emitting the light, the room will be completely brightened up. That is also one proof that light is traveling. Yes, light travels. So how does it travels? So that's what we are going to. Even in the previous class, when we learnt about the shadows, finally we were able to infer from that light is traveling in straight line. Yes, no, children. So light travels in a straight line. See, that is also called as rectilinear propagation of light. Yes, the term light, I hope everyone knows. Yes, so many different things we are learning about the term light. Light is a form of energy and it is a very useful form of energy. You all know that. And also additional to that, you know that interaction of light with the matter. That's what we learned. How it is when it is made to fall and when it is passing through different materials. It is interacting with the different matters in different way. Through the transparent to the translucent and opaque. When it is not able to pass through it, we also learned that shadows are formed. By now, I know that you all are clear about the shadows part. Now, so this is rectilinear propagation of light. Rectilinear, the term means that linear means straight line. Even this was in the when we learned motion chapter also, you came across this rectilinear motion. So that is when any body is changing its position in a linear manner. That is linear means in a straight line. You know what is the meaning of a line? Yes, children. Propagation. Propagation is a technical term that just means traveling. Just now we discussed, no, light is traveling. Yeah, there are many proofs. That's how we are able to get the sunlight. If it is not traveling away from the atmosphere, how we are able to get the sunlight? Getting the sunlight is the very important thing for the life to survive on the earth. Survival of the earth is possible only because we are able to get the sunlight in an appropriate way. Yes, no, children. So now propagation is just that it is getting traveled. So but always the light rays travels in straight line. So when we say something, we will not accept. We need something to get it understood in a clear way. So today we will do some simple 2 activities. I'll explain. So this you can do after the class is over. If it is in the school, you might be knowing that we might have done as a group activity. Nothing. Now nobody can stop us from learning. Yes. So each one of you can do this activity and you can learn it in a better way. So rectilinear propagation means, what does it mean? Light travels in straight line. Straight line. Yes, children. So that is what today through activity we are going to learn. Yes, let us get started, children. Now, just in your room, if there is on the desk, you will keep one candle and you lit the candle. You all know that as soon as you lit the candle, the flame will start giving you light. Yes. Now you take a cardboard or a thick sheet of paper and roll it like a tube. Or if you have any tube at home also, you can make your own tube also with the thick papers. You can stick 2 papers on one above the other end. You can roll it and again stick it and you'll make it as a tube like this. The tube has 2 ends, you all know that. So now what you should do, you all know that once you lit the candle will start giving out light. Yes. So now from the near to the candle or a little distance you have to maintain and you have to observe through using this tube what you have made or already you have. So exactly you have to keep like this and you have to observe. Your eye should be here and you have to observe the flame of the candle. So you will be able to, when you are holding and when you are through the candle, you will be able to see there is no worry that you will be able to see the flame. Yes, children. So now what you have to do, you have to make another tube. So in that tube, you have to make a tube in such a way that there should be a bend like this. The tube should have you will make, again rolling the thick cardboard or rolling thick sheets of paper or chart paper, you can make a tube like this. Now again, with this tube, you have to keep your eyes and you know that flame is there. You should try to observe the flame. What will happen? You will be able to see the flame. Will it be, when you hold it, will it be possible for you to see? No. Why? Because from the flame, the light is traveling at the straight line. As there is a bend here, it will not take a bend, curve, and it won't reach. If it is straight, you will be able to see. Or else you will not be able to see. Same thing happened when we learnt about the shadows also, no? When we are moving the source of light or the object, when all the three were not in a straight line, we are unable to get it. Yes, because the light rays are traveling in the straight line. This is a very simple activity. Simply you can, just rolling also you can perform this. And you can, but after performing, what are you going to understand from that? Light always travels in straight line. Other words, the rectilinear propagation of light. So this is a very simple activity. This can be done in a little bit. The proper way. That is, children. So now we will do a simple another activity to understand this rectilinear propagation of light. That is nothing but light travels in straight line. Now we have taken 3 cardboards, children. A, B, C are the simple cardboards. You can use the match boxes. Small match boxes are there, that also can be used. That sheets, you can take it and you can arrange it in such a way that one after another 3 cardboards you have to take. And mid of each cardboard you have to make a pinhole. Only a small, very small, using a pin you have to make a hole. And other end of the all this setup, when you make 3 cardboards, when you are kept it, you can keep it on a tray, you can fix it. All these 3 cardboards you can fix it. After fixing it, on the another end of the cardboard, you can keep a candle. And you have to lit the candle, and you all know that once the candle is lit, the flame will be put on and the light will start traveling. Now you are going to observe from the other end through your eyes, keeping your eyes through this holes what you have made. When, for example, if the B cardboard is slightly moved, you will not be able to see the flame. If the C cardboard is slightly moved, you are unable to see. This you can, just by slightly moving this, you can understand that whether you are able to see the light or not. First, what you do, you arrange all these 3, and all the 3 holes should be in a straight line. Such a way you arrange, and from this another end you keep your eyes and you observe. When you observe that, you will be able to see the flame. Why? Because from the flame the light is coming out and the light is traveling in a straight line. Now you try to disturb it. How will you disturb it? Just you move the B, slightly you move. That is, this hole should be slightly down. When you keep it like that, you will not be able to see the flame. Again, you keep these 2 in a straight line. Now you move the C like that, somewhere little slightly you move, that hole will go little upper part or the down. Then also you will not be able to see. Why? Because light rays, as per the hole, the light will not bend. Light won't bend. And light will be traveling in the straight line. That is only we call it as rectilinear. Linear means line, as I told you. Propagation means transmission. These all are the terms which you use. Even propagation, if they say, it is meaning the same. Propagation, transmission, traveling, all these are. Traveling is a common term. So when you are learning in the scientifically, when you want to write it clearly about that light travels in straight line, you have to write light propagates, light gets transmitted. Transmission, propagation, both means the same. Simple words for understanding: traveling, propagation, rectilinear propagation of light. You all know what is light. So 3 different things we are learning about light. Light is a form of energy. Light travels very fast. Yes, that is how we are able to, so far the sun is, we are able to get the sun's rays. Yes, because it travels very, very fast. The speed of light, if you know, you will be amazed, or you will be surprised to learned children, it is 3 into 10 to the power of 8 meter per second. Per second it travels so fast. That is how we are able to get the sun's rays. When it is traveling, when you know that it is traveling, how it is traveling, it takes the bend like a waves up and down. No, it will travel only in a straight line. That is called as the rectilinear propagation of light. This is a very basic property and also the very, very important property of light. Yes. So these two activities I want you all to do. Now you will not send me the videos later when I say, but you do and understand this. Yes. One was just with the tube. The next one is with these 3 cardboards. You can, whatever things available in the home, you can do this and you can understand that the light travels in straight line. Further we will continue learning, children. Hope you all understood these 2 activities. Next. Now, whenever we say sunlight, light, we will say light rays. Yes, no children? Light rays. Yes or no? So you all know what is a ray. How you write, how you specify the ray? This is the ray. So what is it? What you all know, you are learning in the maths also. You know the meaning of line segment, ray and all. Yes. So light from the source, it travels in one direction. Yes. Whenever the common term light, you know that in that light there are so many numbers of many rays are bundled together. That is called as this is a single ray, right? Single light ray can be represented like this. You know that why it is represented, because light travels in a straight line. You all know what is a ray also. Yes. So now, but when you say light, we are getting the light from the, just now we had a candle flame. The light rays, it will be not in a single ray. Just when we say the term light, the beam, there are so many rays are combined together. They reach us in a, so many rays are reaching us. So that is called as bundle of rays. This is a bundle. So many rays. Bundle of rays. It is called as beam of light. A beam of light, that means that many rays are emitted from the source. Generally, when you say light also, what does it mean? It is having the bundle of rays, that is the beam of light. So this beam of light can be, they will travel parallel, sometimes they will converge, sometimes they will diverge. That's what we are going to just a glimpse about that, then we will compare. Sometimes they will be parallel and they will diverge, they will also converge. Why I am saying this, I will tell you. See, what are the light rays? Light rays, sometimes they are from the sun. When you are very small child also, when you are asked to draw the sun, you all will be drawing like this, no? A sun with so many, what is this all indicates? Each one is the ray, but there are enormous amount of light is reaching us from the sun. Yes, so many rays. Yeah, so they are all traveling parallel to each other. But as we in the previous class we discussed about how when light depends upon the interacting with the matter. Light, when it is made to pass through different materials, it behaves in a different way. Yes, diverge. That means what? Just now we had a we saw a candle flame, no children. So for the candle flame, once you put on, the light ray will be, it will be illuminating the complete. If in a dark room, it will be illuminating the complete room. Same way when you are, if it is a flashlight, I'll show you the flashlight. See, if suppose it's a flashlight, from this light source, see the light, you can see how it is getting scattered. That is called diverging. From one point, it is traveling in different directions. No children, this is called the diverging. Sometimes the light rays will get diverge from the point source. From the source, it is getting scattered in the different direction. As such, now what you are seeing here. So that is called diverging. Sometimes what happens, it will converge. All the light rays from one source, they will be able to, they can also get converge. That means what? Just we'll see that. So parallel, I hope you all know that. So divergent, diverge, converge. Light rays diverge, light rays converge. So when diverging means what? From one point, so many from the source of light, like this, many rays of light coming and getting scattered. Converging means what? From many rays from source, they're meeting at one point. From one point getting scattered, divergent. Divergent. Divergent rays also we can say now, right? Divergent rays of light. And from many rays meeting at one point, it is called convergent rays, or they'll get converged. So when it happens if it happens in the lens also. So the why we are talking all about this. So you'll be asked not to see the sunlight. Yes, your parents will be saying when you are playing in the playground or out of your home, don't see the sun directly. Why? Can you, after understanding about this, can you think why? Very good. So when we are observing, our eye is having a lens. This all of you know. Yes, eye has a lens. Our eye is like a camera only, no? It is having a lens. And all this, and you all know that sun is an enormous source of energy. So many rays are coming from the sun. So when you are seeing directly, so your eye is having a lens, that eye lens can converge, and this may spoil your eyes. So this is also one of the characteristics of light rays. Yes, that is why we are advised not to see the sunlight directly. Why? Because the lens can converge the light rays, and at one point when all together meet, it may burn and it may affect your eyes. Yes, children. So now you will be surprised. Now, up to now we learned that the light travels in straight line, and also that is nothing but rectilinear propagation of light. And light rays, how they will travel, sometimes they are parallel to each other and they get diverge sometimes, and they will also get converge at one point. That is why we are advised not to see the sunlight directly. Now you are going to you will be interested when I say this word. We are going to make our own camera, children. Yes, it is. Is it not amazing? Now we are going to make one camera this year. That camera name is called as Pinhole camera. This is a very simple device. Generally, you all might be knowing a camera is a complicated device. Our eye is also a camera. Just now I used that. Yes, because why we call it as a camera? Because it captures through the eyes only. Even in the beginning of the lesson we learned, no? Even then light is there. When once you switch on the light, once you get the light energy, your eye is only helping. It is capturing. You all said reflection that day. Yes, that term is also not a very new term for you. It is getting reflected, and we are able to see each other on all the things. Yes. So now one more, to understand better about this rectilinear propagation, a simple device that is called as the pinhole camera. This is a project work everybody is going to do, and it is not going to be so difficult. Just you need two cardboard boxes. You need two cardboard boxes, like your toothpaste, two different size toothpaste box is also sufficient for making this. This pinhole camera is a very old, so many centuries before they use this. For what? For observe. Just now we said no, we cannot observe the sun as such, because it will, our eye lens will convex lens we have, it will converge. So they use this pinhole camera to observe the sun. And also you know about the eclipse now. During an eclipse, always the people are interested to know how suddenly the sun is going to get disappeared for few minutes or seconds. So for all this they use this pinhole camera. It is a very simple device. In this there is no lens, no mirror, nothing is going to be used. Only a translucent sheet of paper and also a pinhole, a hole. So now I will draw the outer structure of the pinhole camera, and there is a clear explanation how to make the pinhole camera. Seeing that, and also you can use the many YouTube links and all there, you can see and you can make a simple pinhole camera, and you can enjoy observing different things, children. So now a pinhole camera will have only the outer structure I am drawing, children. One end of the pinhole camera, there will be a small hole, pinhole. That's why it is called as pinhole. And the other end, there will be a translucent sheet of paper. Translucent paper sheet. It is covered. Yes. So now here using this camera, here there is a tree. For example, we can observe the things which are stationary. This using the pinhole camera, for a few seconds you can capture the images of this using this camera. Only the most of the time it is stationary objects, you will be able to get the images clear. So now this is the image. So from the sun or any from sun, the rays of light are falling. For example, like this, the ray of light. This is the, we will write X and Y for understanding better. Yes, so light rays are falling like this. And you all know that the light rays will, through this pinhole, the light rays will enter and they will reach one point. They will not take a bend or anything. They will straight, they will travel and they will reach one point that on the translucent sheet. Now this is the Y. Yes. So this also again it will be traveling and it will reach this another point. This is the light rays. So when this X here, it becomes X dash. This is the Y dash. So now here on this tree, on this sheet of paper, you will be able to see it is not the shadow, it is not going to be black in color. You will be able to see the image. See, when you see yourself in the mirror, that is not, that day only we discussed, it is not your shadow, right? It is your image. Yes. So here also you will be able to see the image of the tree, stationary object, and it will be in an inverted way. Inverted means straight. See, this is straight. This is inverted. So instead of straight, what will we say in technically? It is erect. This is inverted. Yes, erect, inverted. So now using a pinhole camera, when you are observing, even you can observe a building also. Instead of this, you can observe a building. But here no, I have drawn only both the outer ends. Here the two cardboards will be sliding on one another. You will be adjusting that, how I said that for the shadow. Same way you will be adjusting at one point, you will be able to get the image of the tree. But an image will be a colored image. It will be a colored image. Yes, just as the tree it will be. And it will be inverted. So this is the image. It is not going to be a shadow. Again, after you observe this and all, you will be discussing about the shadows and images. You are only going to say me the differences between here what image you got and the shadows, how they are different. Yes, children. So this is a simple device, pinhole camera. You are going to make. You need only 2 cardboard boxes and you will make one small hole, and the other end there will be a translucent sheet of paper. You have to stick it, and better you have to complete paper with black color. If you cover it, you will be able to get the image here. This you have to put on your hands-on activity. This is definitely you have to do, and you can observe, and then only further we can learn. So this is also here what we are learning from this activity, this using the pinhole camera. Even here you see the light rays are not bending or taking a diversion or anything. It is traveling in straight line. And these pinhole cameras, what for they were used in the olden days? To observe the sun. And sun we cannot see directly. That also I explained why, because it can converge. The lens in the eye can converge and it can burn our eyes. So this pinhole camera, 3 things today, because it is a weekend also you can do this. One is the 2 activities, very simple activities to understand the rectilinear propagation of light. You will do that and you can record it in a A4 sheet paper. Then you will take the boxes at home, 2 boxes which can slide on one another. You read what is given in your textbook also. Just you need 2 boxes. One should move, one will be the bigger one. The smaller one should go inside that bigger one. It should move. And the outer end you will have this pinhole, and the other end there will be this screen like thing where you are going to get the image. And complete box better you have to cover with the black color paper. And by adjusting this, moving this, you will be able to see this image, and that will be not an erect and inverted image. Yes, images will be having the same color. How you are seeing you, whatever dress we are wearing, same. And what type of image when you are seeing you in the mirror, plain mirror that is. How is your image, children? Your image is inverted like this or erect? It is an erect image, right? So now these all will be, even we will be learning further about the shadows, images in our next class. Before that, complete these three activities and try to make your own pinhole camera and observe, and also these two activities on rectilinear propagation. You do it and keep ready for the learn and be thorough up to here for the next class, children. We will further learn about light in our next class. Thank you, children.
Have you ever seen light rays coming through the holes of a damaged roof? You'll be surprised to know, as you can see, that the light rays from such holes produce images of the sun when they fall on the ground. Why? Because these irregular shaped holes in the roof act as pinhole cameras. Now, what are pinhole cameras? Let's first construct one pinhole camera and then let's try to understand the principle. Now, by definition, a pinhole camera is a simple optical device that forms an image without using a lens or a mirror. That's surprising. Now, let's join two hollow cylindrical boxes of different diameters in such a way that one box can just slide within the other. Now what do? We make a small hole in the larger cylinder there, and also make two holes in the smaller cylinder, the one inside. Fine? But there is one care you need to take. The inner hole has to be rectangular and the outer hole has to be circular. We now fix a translucent paper, say a tracing paper, on the rectangular hole, because that's going to act as a screen. Now, very importantly, these two cylinders must be enclosed so that you can prevent light from entering the larger cylinder. That will mess up our image. Now, use this pinhole camera and try looking at a tree. Surprise! A clear image of this tree can be obtained on the screen if you slide the smaller cylinder back and forth. Now, how exactly did it happen? Let's look at this diagram. The tree is, say, MN. M is the topmost point, N is the bottommost point. The light rays coming from the bottom of the tree, that is N, they pass through the small hole and strike the screen at the top of the axis, N dash. Can you see that? And the light rays coming from the top of the tree, that is M, strike at the bottom of the axis, that is M dash. Now what happens as a result? As you can see, an inverted and also a much smaller image of the tree is what you get on the tracing paper. Remember the tracing paper which acted as a screen? Now the size and contrast of this image, it can be adjusted. For that, all you need to do is slide the smaller cylinder. Also, one more thing. The image depends on the size of the pinhole. The smaller the pinhole, the sharper will be the image. And of course, vice versa.